In this lesson, we're going to go over statistical tables and graphs. Specifically, we'll become familiar with frequency tables. We'll learn to distinguish between the two types of data, and we'll learn how to build a histogram. So some definitions, frequency tables. So at a basic level, a frequency table must contain two columns. The first column will list the categories of data. So this could be letter grades, flavors of ice cream, just different ranges of numbers, whatever the categories are of the data set. The second column lists the frequency of each category, and the frequency means how often it occurs in your set. Another definition is relative frequency. So relative frequency is the fraction or percentage, and I'm going to underline percentage because that's mainly what we'll be looking for, of the data that falls into that category. So the way to calculate that is to use fraction. Relative frequency is the frequency in the category divided by the total frequency, and then to get the percent, you would multiply by 100. Okay, another term that we'll use is the cumulative frequency. So the cumulative frequency of any category is the number of data values in that category and all preceding categories. So let's say we have the third column of the third row of a chart. The cumulative frequency would be rows 1 plus 2 plus 3. Okay. So example number 1, consider the following 20 scores from a 100-point exam. So we have our data set of scores. The problem in your book says determine the appropriate bins, but we'll always give you those. And what bins are specific groupings. So when you have your data set that contains numbers, sometimes it's helpful to group them so that when you go to plot it, we're looking at those groupings of numbers. Okay, so in this case, we're going to use 5-point bins. So this would be like 95 to 99, etc. Okay, and the problems in the homework, I believe, give you that as well. And we'll make a frequency table, including the columns for relative and cumulative frequency. So in this case, we're going to have a frequency table that has 4 columns. So the two basic columns are, column 1 is the category, column 2 is the frequency, and then this problem wants us to include relative frequency and cumulative frequency. So the first thing that I would do here when you're working with a data set and we're going to group the numbers, notice we're grouping 95 to 99 together. So it'll be helpful to see these values in order. So I've already written them down. Make sure you get the same thing when you write these as least to greatest. Okay, so I have my values here written least to greatest, and we're dealing with 5-point bins. So notice that 95 to 99 has 5 points. 95, 96, 97, 98, 99. Okay, so make sure you're counting those up. So, and then our bins will go down from there. So the next set would be 90 to 94, and so on. So on the next slide, I have the chart built, and so I'm going to flip back and forth between this chart. It has the 4 columns, as I mentioned. It has our bins, so there's 5 numbers, 5 numbers, 5 numbers, 5 numbers, 5 numbers, and 5 numbers. And then in order to determine the frequency, you count how many are in that category. So in this case, our categories are those 5-point bins or 5-point groupings. Okay, another way to think of bins is a specific grouping. So 95 to 99. There's only 1. 90 to 94, there's 2. 85 to 89, there's 3. 80 to 84, we have 3 again. 75 to 79, this is a big one. 1, 2, 3, 4, 5, 6, 7. And then 70 to 74 would be 4. Okay, and notice that the sum of the frequencies should equal the total, meaning that they're all accounted for. One thing to note is that the categories are the 5-point bins. It doesn't mean that there's 5 in each category necessarily. Notice the frequency of 95 to 99 is 1. It's talking about how we split up these categories. That's the 5-point grouping. Now, in order to calculate relative frequency, we take the frequency of the category divided by the total. So the relative frequency would be 1 over 20. If you put that in your calculator, you would get 0.05, or as a percentage, it occurs 5% of the time. Okay, so I'm going to do relative frequency, and then we'll move on to cumulative frequency. Second one would be 2 over 20, which as a percentage comes to 10%. The next would be 3 over 20, which would be 15%. Sorry, my desk breaks sometimes. The next is 3 over 20, which would be 15%. 7 over 20, which would be 35%. And then 4 over 20, which would be 20%. Okay? And if you add up all the percentages, this should equal 100%. Okay, so the cumulative frequency now is the sum of that category and any preceding category. So for the first row, the cumulative frequency is just 1. It's that category plus any preceding categories. For the second row, we add the frequency of that category plus the preceding category. So this would be 3. We would keep going. Third column would be 1 plus 2 plus 3, which is 6. This fourth row would be 3 plus 3 plus 2 plus 1, which would be 9. This next one would be, or you could just add 9 plus 7 equals 16. And then the last one would be 16 plus 4, which would give us 20. And so our total is 20. So essentially what the cumulative frequency is telling us is how many are in that category and above it in this case. So if we look at, let me switch colors here. If we look at right here in the green, we have 9 that had an 80 or higher, okay? Or at the very bottom, if we look at 20, 20 had 70 or higher. So that's able to sum up our categories for us. Okay? And so I have this frequency table filled out for us again. So we have the frequency, the sum of the frequency of each category should equal the total. The relative frequency should equal 1 or 100%. I believe there may be questions in your homework that talk about the relative frequency as a decimal. We'll specify percentages, and then your cumulative frequency includes that category in any category before it. Okay, so take a picture of this, write this down. Next, we're going to talk about making a histogram. Okay, so when we make a histogram, we have an X and Y axis, or horizontal and vertical axis. With a histogram, remember that we have bars that have an equal width and that are touching each other because we have a continuous data set. So this is going to be our categories, or our scores really, categories. And then on the Y, we'll have the frequency, or number of times that it occurs. So if I look back, my highest frequency is 7. So I'm going to make sure I have 7 notches vertically. And then I have 1, 2, 3, 4, 5, 6. So I'm going to make sure I have enough room for 6 bars. So let's start here. 1, 2, 3, 4, 5, 6, 7. And then I'm going to make these as equally spaced as possible. 1, 2, 3, 4, 5, 6. Okay. So first, when we're labeling this, these are ordered biggest to smallest in terms of this table. So my highest value is 99. So when I label this part right here, it's going to be 99 to 95. The one below it would be 94 to 90. Okay? And so I guess you could have written these values in greatest to least or least to greatest. Either would have worked. So for 99 to 95, it had a frequency of 1. So my bar will have a height of 1. For 94 to 90, it had a frequency of 2. So my bar will have a height of 2. The next category would be 89 to 85. And that had a frequency of 3. So my bar is going to have a height of 3. So if you notice, I'm going to use I would just kind of draw it over and make sure that it ends up at that height. Sorry, I keep clicking over. 80 to 84. So we have 84 to 80. and that had a frequency of 3 as well, so it's the same height as the bar next to it. Now we have 79 to 75, and that is the tallest bar, so I'm going to kind of drag over. And then, oof, my bars are getting a little swervy there. And then lastly, we have 74 to 70. And that had a frequency of 4, so the bar height should be 4. So it's like about here. Okay. And then if you want to take a look at what the cumulative frequency is telling us, 99 to 95 had a cumulative frequency of 1. So 99 to 90, this is 2, but together these make 3. So the cumulative frequency here would be 3. So that's just a visual of what those cumulative frequencies are telling us. Okay? So this is how you would make your chart. It's very important whenever you're asked to sketch something to make sure you have your horizontal axis and your vertical axis labeled so that we know what's being measured here. With the histogram, the bar should touch because it's a continuous data set. Okay. So a couple more things. Data types. So we have qualitative data and quantitative data. So qualitative data consists of values that can be placed in non-numerical categories. So I think of it in terms of, I guess, categorical data. So things like what we've talked about, seasons of the year, spring, summer, winter, fall, letter grades, ice cream preferences, different things like that. Quantitative data, I kind of see the word quantity in there, so I think of it in terms of numbers or measures or counts. So I suppose numbers can be put into categories like we did with the bins, but when I think of qualitative, I guess I think of like things like movie genres. And then another note, when dealing with quantitative data categories, it is helpful to use a group or a bin, so like we did on the previous example, to make sure you cover the range of possible values. Okay. So just a couple of examples with categorizing data. So determine whether the following are qualitative data or quantitative data. So brand names of shoes in a consumer survey. So we're talking about brand names here. This would be qualitative data. Miles driven in the months of September. Can miles be counted or measured? This would be quantitative. Consecutive days without rain in Las Vegas. Too many. Just kidding. It can be counted, so it's quantitative. So if you have any questions about this section, feel free to reach out to me.